In today's class, we are going to see the Gauss elimination method of the Engineering Mathematics 1 chapter linear algebra. So one of our subscriber, or you can say viewer, have asked me to solve this problem. So I'm continuing with the class. We have the equation x1 plus x2 plus x3 is equal to 4, 2x1 plus x2 minus x3 is equal to 1, x1 minus x2 plus 2x3 is equal to 2. We can write first step as coefficient of the matrix A. So the coefficient of the matrix A is nothing but the numbers of this coefficients x1, x2, x3. First row, first equation 1, 1, 1, 1, 1, 1. This is 2, 1 and minus 1, 2, 1 and minus 1, and this one 1, minus 1, and this is 2. This is called coefficient of the matrix A. Next we need to write augmented matrix, which is nothing but both the sides you have to write 1, 1, 1, 2, 1, minus 1, 1, minus 1, 2, and here you can write the colon and write down the right side. This is 4, 1 and 2. This is called the augmented matrix. Let us reduce the matrix using row operation, which is echelon form. We have to convert it by using the elementary operations. The first thing what we need to do is we need to make a triangular section type here. To reduce is the triangular section, upper triangular, and these terms should be reduced to 0 such that the last term, that is the x3, should be alone here, so that it will be your answer for x3. So let us do the operation. You can see this r1 is having the number as 1, so let us take this one as a standard row. So let us solve r2 row. R2 is such that it should be r2 minus 2 r1. This you can solve it such that it will become 0, this one. And this one you can see r3 row is 1 already, so no need to multiply the term. So r3 you can change it to r3 minus r1. R1 is the reference in the first step. So the augmented matrix becomes, now you can see here, this will become what? R2 is 2, 1, minus 1, 1, 2 r1. This will become 2. This will become 2 r1 means minus multiplied, minus 2, minus 2, minus 2 and minus 8. So now you subtract it, it will become 2 minus 2. First matrix, first row as it is 1, 1, 1. This is 4. And the second row becomes 2 minus 2 is 0. Then 1 minus 2, it will become minus 1. And minus 2 minus 1, it will become minus 3. This will become 1 minus 8 because 4 2s are 8. So it will become minus 7. Next one, directly you have to subtract. 1 minus 1 is 0. Minus 1 minus 1, minus 2. And 2 minus 1, minus 2 plus 1. So here 2 minus 1, it is 1. And last one is minus 2. This is your final matrix you'll get. Now you know that this has become 2 zeros. Still you need to make this one is also 0. That will be easier for you to solve. So for this we'll take the operation as r3 you need to remove. So we will take r3 operation as r3 minus, so you can see 2 r2 you take, 2 r2, r3 minus 2 r2. What will happen here now? The augmented matrix becomes, now first one as it is 1, 1, 1, and second one back becomes same 0, minus 1, minus 3 and minus 7, and the final row becomes now minus, this is 0 as it is, minus 2 plus 2, it will become minus minus plus, it will become 0. Then 1, 2 3s are 6, minus into minus plus 6. Then 2 7s are 14, minus into minus plus, minus 2 plus 14 becomes 12. So you can see here the matrix we got here is a very simple form, reduced form to the upper triangular form. Now you can write down the linear equation for this as first row is x1 plus x2 plus x3 is equal to 4, and second one is minus x2 minus 3x3 is equal to minus 7, and finally we have this one is not 6, sorry, you get 1 into plus 2 3 is 6, minus 1 is plus 6 plus 1 is 7 you'll get. So here, so 7x3 is equal to 12. We can solve the final equation now. X3 is equal to 12 by 7. Suppose this is first one, second one, third one. So first equation you got the value of x3. Now to get the value of second one, you can further solve it. So x2, you can write second equation as like this. X2 is equal to 7 minus 3x3, which is nothing but 7 minus 3 into x3 is 12 3 is 36, 36 divided by 7, which is nothing but if you take the LCM you'll get 13 by 7. X2 is 13 by 7. Now substituting x2 and x3 in one equation, you'll get x1. x1 is equal to 4 minus of x2 minus x3, which is nothing but 4 minus 13 by 7 minus 12 by 7. Finally you will get, if you take the LCM as 7, you'll get 3 by 7. So you can see x1 is 3 by 7, x2 is 13 by 7, x3 is 12 by 7. This is what the Gauss elimination method. If you have any doubt, you can comment me, and please share our channel and subscribe our channel and learn with me in this lockdown.